Hello students, welcome back. I hope you must have seen the previous video SOP reduction using K-map. Today I brought for you POS reduction using K-map. So let us see. Karnaugh map is a graphical display of the fundamental products, that is min terms, or sums, that is max terms, in a truth table. It was originated by a great mathematician, Maurice Karnaugh. This all fundamentals just I am revising quickly as you must have seen the previous video, but if you have not seen, so you can understand what is the K-map. So it is made up of certain number of squares, each square representing a min term or max term. For a function of n variables, there would be a map of 2 to the power n square. So in K-map actually we draw a map which contains a certain number of squares, and suppose if there are 3 variables, that will contain 2 to the power 3, that means 8 boxes. So let us start. Draw an empty K-map for given function. Suppose if 3 variable K-map representing max term, you want to draw a map. So as you can see, 3 variables means 8 boxes. So you will make 8 boxes where one variable will be this side and remaining 2 variable will be this side. Okay? Then you will write all possible values of x, 0 and 1, possible values of yz. As you know, the possible value of yz is 0, 0, 0, 1, 1, 0 and 1, 1. But here we write 1, 1 first, then 1, 0. Why? Because K-map follows gray code. Now what is the gray code? Gray code is the binary code in which each successive number differs only in one place. That means कि when we write the arrangement of these numbers, we have to ensure कि either 0 is changing into 1 or 1 is changing into 0. For example, you can see after 0, 0 we are writing 0, 1. So 1, 0 is fixed and 1 is 0 is changing into 1. After 0, 1, why we are not writing 1, 0? Because if you write 1, 0, so the gray code will be fail. Both the 0, 0 is changing into 1 and 1 is changing into 0. So that's why we bring this number first, 1, 1, where you can see 1, 0 is changing and this second 1 is constant. So this particular order is known as gray code. So while drawing the K-map, we have to use gray code only. Okay. Now it is a POS reduction. So here we will write the max term. 0, 0 max term is y plus z. As you know, in max term the bar is on 1. So y plus z bar, like y bar plus z bar. So now let us see the 4 variable K-map. For 4 variable K-map, we have to draw a box of 16. Okay, where both the side gray code you will follow, this side AB and CD, and gray code 0, 0, 0, 1, 1, 1, 1, 0, and according to the gray code you will write the max term, like here C plus D, C plus D bar, C bar plus D bar. And this box numbering, this I think we have discussed in the last video. Now let us see again why this number is 7, because actually the binary equivalent of 7 is 0, 1, 1, 1. Okay, why this number is 12? Because the binary equivalent of 1, 1, 0, 0. So these all are according to their binary equivalent. Now the next step, we have to map the given function by entering zeros in the corresponding squares. So that blocks we will get in the question where we have to fill the 0. Now the next one, encircle adjacent zeros in the form of octets, quad and pairs. As you know, octet means 8 adjacent ones, quad means 4 adjacent ones, pair means 2 adjacent ones. So we have to find the group. Okay, let us see some combination. Like if this type of combination is there, 2 times 0 is there, so we can form a pair. Here 2 0 is there, we can form a pair. 4 zeros are there, we can form a quad. 4 zeros are there, we can form a quad. Okay, like 8 times zeros are there, we can form an octet here. This type of combination is there, 4 0, quad and pair. Let us see. Let's see some more combinations. In this you can see directly we are not able to group. So here we can use map rolling concept. Map rolling means we can consider the top and bottom edges are touching with each other and left and right edges are touching with each other. So in this way we can form two pairs here using map rolling. Suppose if this combination is there, we can use map rolling for forming the quads. If all four corners are 0, then also we can use map rolling. Like here we are rolling map twice. Once top and bottom edges are touching with each other and one left and right edges are touching with each other, so that will form a quad. If this type of combination is there, here you can see firstly we can draw a quad. After that, this 0 we can take common from this quad 1 0 and we can form a pair. This is called overlapping. So map rolling is different. This is map rolling and this is overlapping. So we can use overlapping, like here this is the overlapping. Okay. So these are the some common combinations. While solving question, even we can get any other combination, so that by practice you can improve. So now let us see the final difference between SOP and POS. So while drawing SOP, generally we use min terms. Okay, on the top we have to write min term. In POS we use max term. In SOP we fill ones in the respective blocks, means which numbers are given in the cardinal form in the question. In those boxes we fill 1. In POS we fill zeros in the respective box. And in SOP we use shorthand notation small m with plus sign to represent a group. For example, M2 plus M3 plus M6 and plus M7. And in POS we use shorthand notation capital M with dot sign to represent a group, like capital M2 dot M3 dot M6 dot M. So these are the three fundamental difference that we have to take care while drawing the map. Rest basic fundamentals are same, drawing of the map, taking group, okay, this everything is same, only these three important things that we have to consider. So now let us see actual question. Suppose if question is there, f a b c d pi 3 5 7 11 13 14 15. So how to draw? You can see here 4 variables are there, so we will make 2's to power 4, that means 16 boxes. Then starting 2 variables a b, we can take this side, cd this side. Gray code we can write 0 0 0 1 1 1 1 0, and according to gray code we will write here max term because it is a POS. So as you know, in max term we put bar on 1, so that's why this is C plus D bar, C bar plus D bar, like this same way. This numbering as we have discussed earlier, all the numbering. Now we'll start filling the zeros in this respective blocks. So like in 3 number, then 5, 7, 11, 13, 14 and 15. After that we will find the group. You can see here one quad is possible here and one quad is possible here. So we can make one quad and one quad. And now here we can use overlapping concept with pair. So total 3 groups are there, 2 quads and 1 pair. So now how to reduce quad 1? We can see M3, M3, M7, M11, M15. This is quad 1. Quad 2, M5, M7, M13 and M15. And pair number 1, that is 14 and 15. So now for finding the answer, quad 1, you can see here, this is only in a one particular column. So nothing is common from row side. So column is common for all. So C bar plus D bar. Now in the second group, you can see here 2 rows and 2 columns are involved. So 2 rows, what is the common value? B bar, and column, what is the common value? D bar. So that's why B bar plus D bar. In pair, a single row is involved. So A bar plus B bar from row side. Column side, 2 columns are involved. So common is C bar. So final answer is A bar plus B bar plus C bar. So this is the reduction of individual groups. Now the final answer, as it is a POS, product of all the sums we have to write. So C bar plus D bar dot B bar plus D bar dot A bar plus B bar plus C bar. So this is the way we can simplify an expression using K-map. Thank you.